Okay, guys. We're going to go through these examples, and I'm going to do 3 or 4 of them, and you should get the rhythm of it after that, okay? And hopefully there'll be some senior kids in the classroom to help you. Okay. This will be the first circuit that we do, the first complex circuit. And we look at that thing and we ask, well, what do we do first? Well, the first, in all these, we want to get the REQ. We want to get then the total current, then get the current through and the voltage across every resistor, or voltage drop in every resistor, okay? So we look at that thing there. What are we going to do? We want to get down to an REQ. Are we going to do series or parallel first? Well, the deal here is I can't do parallel first because I got 2 that are in direct series here, okay? So I'm going to do the series first. And as long as there's no junction between 2 resistors, you will do the series first, okay? So we do this. And that's 2 and 4, you've added together for REQ in series, it's going to be 6. So you do this. Okay. Oh, assume there's 2 sig figs on the 10 volts. I'm not going to write whatever, you know what I mean? It's 10 volts. And that's going to be 6 ohms. It's going to be 5 ohms. Now what do I do? Well, they're always in parallel, so I have to do that, okay? And I think we'll do that down here. We'll scroll down a little bit. Okay. So we come on down to do this. And I expect you to do this on your own paper too. Show me what you're doing, because I cannot read your mind. So 5 and 6 in parallel gives you an REQ. We'll do that in a minute. Let's just draw it first though, okay? Okay, 10 volts on this. And what's the REQ of 1 over 6 and 1 over 5? Let's do that. Sheesh. I'm going to do it here, and then I'm going to erase it because I need the room, okay? So I do REQ that one. And I do the fractions with the least common denominator, but you always end up with the decimal. You don't have to do it with the fractions, but I do. If I can. All right, common denominator for 6 and 5 is going to be 30, so we do this. Let's see, 5. I'm not going to sig figs with this, but when I get done, I'll put sig figs on it. All right, so that's going to give us 1130, 1130s. And REQ, 1 over REQ equals that, so I flip both sides. Now, it's really just cross multiplication, right? Okay. So do that. So therefore, we get REQ equals 30 over 11, which equals, I cannot remember this. So 30 divided by 11 equals 2.7. That's the REQ for that thing, for those 2. So 2.7. There you go. Now I'm going to erase this, and if you don't, go ahead and just pause if you want to. Okay. There. Good on that. Okay. So now we got the REQ. Now let's get the total current in the circuit from the REQ. We do that over here now. So we have V equals IR. We're doing, let's see, so we want to get the total current divided by R. And that's going to be 10 divided by, let's see, 2.7, which equals 3.7 amps. There you go, and that's your total current. So that's the current through this thing right here. So I'm going to say I 2.7 equals 3.7 amps, okay? And your voltage drop in that thing is 10 because voltage in, voltage out, right? 10 must be out because it's the only R in the circuit now. All right, you pause if you want to. I'm going to erase it. Be sure I did it right. We're good to go. All right. All right, so now we're going to work it backwards. I want you to look always get the bigger picture of what you're doing, okay? Okay, so we've got 10 volts in this thing, right? And I'll put this even though it's kind of redundant. The voltage in the 2.7 equals 10 volts. Okay? That's 2.7 right there. And okay, so what's the same about these two resistors as this one here? This one came from two in parallel, therefore same voltage in these as is in this, the REQ of it, okay? So they both have 10 volts. Let's do that. Let's see, the V6, 16 for the 6 ohm resistor, is 10 volts. Same thing here, the V5, man, I'm gonna run out of room. I'm gonna erase this in a minute. The V5 also equals 10 volts. All right, now I'm gonna erase it. If you want to, pause that. All right, that should be in your notes, so there should be any problem with that if you need to refer back to it. All right, 10 volts there, 10 volts there. Now, let's see. I got the voltage in this thing, don't I? So I'm done as far as the voltage. Let's get the current, and then we're done with that one, okay? So we do this. We know V divided by R. Let me do this. V5 divided by R5 equals I5, right? Okay? It just comes from the V equals IR equation. So we have this voltage, it's going to be 10 divided by 5 ohms. Equals 2.0 amps. That's the current in that thing. Okay, so I'm gonna put it right here. Just leave it alone. But you're done with that. You've got the voltage, you've got the current in it, right? Now we're done with this one. That is out of the way. Now we have not done these two. And these two come from this REQ right here. Okay? So this REQ comes from two in what? In series. So same what? In other words, these two have the same what as this, voltage and current. Well, because they're in series, they have the same current. So therefore, we got to get the current in this, and that's going to be the same current in these, okay? Let's get the current in this. And let's see, let's pull up the amp. I'm going to do this. You know, and I've got to erase this, guys, once I get this done, because this is the only thing that you will see. Everything else will be too dull for the camera, at least for this in focus anyway. Now let's see. V6 divided by R6 equals I6. Which equals V6 is going to be 10 divided by 6, and therefore I6 equals what? 1.7. Current in that one, okay? All right. That's also going to be the current in these two right here. And guys, what you're doing is leave yourself tons of room so you have room to put all these stuff in and get as organized as you possibly can. All right, so I'm going to do, so both these have 1.7 amps. So I'm going to say this, let's see, I2 and I4. Everybody good? All righty. By the way, what's on this thing, what's a good test to see if I'm correct on my current in this and this? In other words, the current in this and this, right? Well, the total current was going to be 3.7 amps, right? This current, the current splits here and then comes back together. So this is the total current here, but these two currents should add up to that current there, right? The total. All right, so let's make sure that's the case. 1.7 here, 2.0 here. Therefore, this does add 3.7, which is the total current. It's a good check to make. All right. Now, I want to get rid of this stuff because it's really my way. Okay, let's do this. We're good on that, and we're almost there. I'm going to get the volts in here, and then I'm done, right? All righty, and so let's get the voltage here first. I'm going to come down here on this one. So V equals IR, so V2 equals I2 R2, which equals, the current's going to be 1.7, and R is going to be 2. Get rid of this, which equals 3.4 volts. Okay, and let's check out this in here. V4, R4, I4, R4, 1.7 amps times 4 ohms. And that's going to be what? 6.8. Okay. 6.8 volts in that thing, and then you're done. So you have 3 volts here, 6.8 volts here. What's it check to see if I'm right on this? Well, I know as you go from here to here, you're losing all your voltage, right? Whether you go in this branch or in this branch. But here, you're losing it gradually. Here, you lost it all at once in the 5 ohm resistor. So how much did you lose here? 3.4. How much did you lose here? 6.8. The total is 10 because 10 went in here, 10 came out here. All righty? Everything good? I'll leave it at that. All right, that one's done. Let's go to the next one now. Let's see. Let me check something. And let's go to the next one. Boom. We did that one. What was the other one I missed? No, same stuff. All righty. And let's see. Let's do that one. I'm going to rewrite this thing down. You got 4, 6, 12, and 10 volts. 4, 6, 12. Let's do that one. So I have this. I can't remember what it was. 4, 6, 12. Okay. And 10 volt battery. All right. Write that down, then we'll do that. And all this time, guys, have somebody up here pause this when you need to, okay? Okay. What am I going to do first here? Series or parallel? I cannot do direct series because there's a junction here. In other words, you can't do direct series if there's a junction between the two resistors, okay? These are in direct parallel, okay? All right. So let's get you this. We're doing parallel first. And let's do this. Back here, 10 volts. And this is 4. Guys, assume two suffix on the 4 there. 4.0. Okay, now I have to do these in parallel real quick. I'm going to do it and then erase it, okay? Like I said, I do it on that board, but you wouldn't be able to see it. So we do this 1 over R cubed. 1 over 6 plus 1 over 12, right? All right, common denominator is 12. And then we'll do that. And pop it up. So we have 1 over R cubed. It's going to be 2 over 12 plus 1 over 12, which equals 3 over 12. All right? We're going to flip them. Okay? So that means R cubed equals 12 over 3, which is 4 ohms. That's your REQ, those two in parallel. All right, once again, I'm going to cruise, guys. When you need time, just make sure the guy pauses it for you. Okay, pull it up here. Now I'm going to erase all this mess. Good on that. And let's see, 4. Interesting. Okay. And that's going to be good on that. Got that. Now, where do I go from here? They're obviously in series then, right? So let's do that. Okay. So 4 and 4 is 8. So I have this. That's 8.0, guys, in case you can't see it. And it's 10 volts, as I recall. Yep. Now, once again, your REQ is 8. Now, once you get your REQ, get your total current. So V equals IR. So V divided by R equals I. Which is going to be, what? 10 divided by 8. So therefore, your total current is going to be, let's see, 1.3, 1.25 rounded. Let's see. And I don't like rounding that big like it is because it's going to set everything off a little bit, but that's just the way life is. Hook it up. That's your total current. Now we go backwards again from this back here. Now what do I, this REQ came from 2 and what? series. So because it comes from resistance in series, they have the same what as this. They must have the same current. So they both have 1.3 amps. So I'm going to do this. I4 is 1.3 amps. And this I4 is 1.3 amps. We're almost done with this one, right? Because we have the current, we got to get the voltage, and we have to get the voltage, and then we're done with that. Let's get the voltage in this one, okay? I'm gonna, like I said, I wish I had room to go right across, but I don't. Let's do this. So I need V4 then, right? I'm gonna do this and then erase it. So therefore V4 equals 1.3 amps times 4 ohms. And what is 4 times 1.3? It's going to be 4, it's going to be 5.2, right? V4, 5.2 volts. Okay, and I'm going to put that up here. V4. Okay. So I got the voltage there, and I'm done with that one. I've got the current and the voltage. Okay, let's get rid of it. All right, now, but we're not done with this one right here. This comes from 2 in parallel, right? From these two right here. Therefore, they have the same what as this? Same voltage. Okay? So we got to get the voltage here. Oh, I'm going to do this because that was 4 volts and that's 4 volts, and they have the same current. Therefore, I'm sorry. That's 4 ohms and that's 4 ohms, and they have the same current. Therefore, same voltage drop, right? All right, so we're going to do that. Man, I hate that. That came out really. I knew it was going to come off bad, but you know, that's the way it is. This is 5.2 volts too. This should add up to what? You're dropping voltage as you go around. 10 volts in, 10 volts out as you go around, right? It goes to 10.4. The rounding really messed it up, but it's not wrong. All right. So both of these have 5.2 volts then, don't they? Let's do that. Let's do the V6. 5.2 volts, the V12, 5.2 volts. Okay, I hope I didn't make some stupid, I don't think I made an error anywhere on that thing though. I could have, I don't think I did. All right, let's get the current in both of these and then we're done, right? Let's do this one. And we'll have, we're going to do the current in 6 equals V6 divided by R6, right? I'm just kind of, going shortcuts because I know now you should know what you're doing on this stuff. You've been doing ad nauseum. All right, so it's going to be 5.2 volts. And let's not put the amps in there yet. Divided by 6 ohms. And I suppose that should be 0.8. Let's check and make sure. Let's see, 5.2 divided by 6. And let's say 0.87. 0.87 amps. That's an 8, guys. Yeah, it looks stupid. 0.87 amps. Okay, we're done with that one. Now let's do this one, okay? Oh, I'm sorry. Let's do this one here. Now pause it because I'm fixed to erase this, all right? Once again, on your paper, you can give yourself tons of room on this and make sure that you do. So let's pull this one down. And once again, I12 is V12 divided by R12. Okay? And it's still going to be 5.2 volts divided by 12. So 5.2 divided by 12 equals 0.43 amps. Okay. And we're done. That's got all of them, okay? And by the way, this current and this current should add up to what? The total current, which is 1.3 amps. And I forgot what that one was already. I could go back, but I don't want to do that. But it does add up right. Okay. Oh, it's 0.87, that's what it was. Check it out. 0.87 plus 0.43 equals 1.3. Very good. All right, that's the third example. And once again, these are not that hard, just make sure that you get them right. All right, next one. What are we at here? Let's check out this one. Okay, so we have 3, 4, 1, 6, 8. 3, 4, 1, 6, 8, and 12. 3, 4, 1, 6, 8. Let's do this. Assume 2 sig figs on these guys. I'm just trying to get out of here. 3, 4, 1, 6, 8. There you go. And let's make the battery 12 volts, or the power supply, whatever it is. EMF. EMF means electromotive force. It means voltage. All right, so we got that thing. We want to get the current and the voltage in all those resistors. Now let's do that. All right, what are we going to do first here? We can't do it in series because there's a junction here with these, there's a junction here with these. Okay, you cannot do series with a junction between. So obviously you're going to do parallel. Let's do that parallel and that parallel, and I'm going to do this, and then I'm going to draw it and then calculate it. So we have this. That's this one right here. That's the 1 ohm. And I got to get these two. That one came from this one. Let's get that first, okay? So it's going to be 3 and 4. So let's do this. I'm going to erase it, but once you give yourself plenty of room on your paper. All right, common denominator is obviously going to be 12. Let's see, 4 over 12, that's, sheesh, I cannot write. And 3 over 12. Add them together, you get 7 over 12, then flip them. All right, so REQ equals 12 over 7. Once again, I'll put 2 sig figs in there when I finally get my data going. 12 divided by 7. Which is 1.7. So this equals 1.7. That's that one right there. That's 1 ohm. Let's get this one right here, guys, okay? Once again, pause it if you need to. Okay. Now let's look and see which one I'm missing there. I got to do the 6 and the 8 in parallel. Let's do that. Common denominator, what, 24? Okay, so let's do that. Uh, 4 over 24. And 3 over 24. Okay, this is going to be 7 over 24. Flip it. What's that? 3 and almost a half. Check it out. 24 divided by 7 equals 3.4. All right, 3.4 ohms. Let's put that up there. There you go. Like I say, assume that's 1.0. All right, now we're almost there. Now easy to do this, right? They're all in series. So it's going to be this. Smallest. 12 volts. And let's see, 3.4, that's going to be 4.4. And let's see, make sure I'm not full, I'm tired. 4.4, 5.4, and then 6.1. All right. All right, let's get our total, that's the REQ. Get your total current. do that. Uh, 2.0. It's 1.96 rounds to 2.0. That's your total current. Okay. And that means, okay, blah, blah, blah. Let's go on that. Good, good, good. Okay. Now let's go back to, from this to these three. What's the same of this one and these three? Well, this REQ comes from 3 in series, so therefore same current as the REQ. And the REQ was, what was it? 2.0, so all these are 2.0 amps, all right? So I'm going to do this I 1.7. I'm not going to have enough room. All three of these guys are 2.0 amps. I'm going to put this down here. I1 equals 2.0 amps, and I 3.4 is 3.4. No, stupid. There you go, all of them at 3.0 amps. Now this one is that one, so we have everything but the voltage in that, don't we? Let's go ahead and finish that one out then, okay? And then we'll work on these two after that. So here we go. Let's get our voltage. So we do V equals IR. It's going to be the 1 ohm, 1 ohm, 1 ohm, and let's do this. It's going to be 2.0 amps and times 1, which equals 2.0 volts. That's got 2.0 volts in it. So what I'm going to do is I'm going to erase that and then write it there. So go ahead and pause it or whatever, and then I'll put it right here. V1 equals 2.0 volts. Okay. And let's put our current up there too. The current. So that's volts, yeah, this is current. All right, so that one's done. Now let me erase this. Now let's get the other two. Okay, look at this, guys. This one comes from these two right here, which are in parallel. So if the REQ comes from 2 in parallel, same what? Same voltage. So, oh, we got to get the voltage for that and that, don't we? All right, let's do that. Shoot, get this voltage here. Don't pull that one down and do it, okay? All right, so V equals IR. Oh, this is 1.7 stuff, which equals, let's see, the current is going to be 2